Okay, so this is one of these areas that it really is going to help to just learn stuff, unfortunately. So sometimes anions are not just single anions. They are formed from two or more elements bonded together by molecular bonding, which then become charged. They then gain one or more electrons to form what's called a polyatomic ion. So more than one atom joined together to form an ion. So some of them you probably know. You probably already know stuff like carbonate or sulfate or whatever. So I find it's useful for you to just kind of break them up into groups of what you know and what you don't know. There is a relationship in terms of the number of oxygens that related polyatomic ions have. For instance, nitrate, the 8 ending is usually associated with having the most oxygens. No, I haven't actually quantified this. I've just said the most because it does depend which one it is, whether it's like 3 oxygens or 4 oxygens, so you can't deal with the absolute number of oxygens. So nitrate is NO3 minus, and then nitrite has one less oxygen with NO2 minus being its formula. So 8 has the most oxygens, and the I ending has one less oxygen. So just go through and pick out the ones you know, focus on learning the ones you don't know. It really will make your life a lot easier if you can translate between the name and the formula of polyatomic ions, and that does include the charge as well. So starting up with this one, we're coming in with a hard one, which people don't necessarily know, haven't already come across, is the chromate anion. So there are bonds between the chromium and the oxygen. So that is a subscript 4. And then the whole thing gains 2 electrons to form the chromate anion. Okay. CO3 2 minus is the carbonate ion. Carbonate ion. The hydronium cation, there's only 2 polyatomic cations that I expect you to know. One is ammonium, which is NH4, which is formed when ammonia, NH3, gains a proton, NH plus, to form ammonium, NH4 plus. The same thing can happen with water. H2O is water, and it can gain a proton, an H plus, to form the hydronium cation, H3O plus. This is very important in Gen Chem 2 when you do a lot more acid-base chemistry and stuff. So that is H subscript 3 O superscript plus is the hydronium cation. And then lastly, this guy right here is the chlorate anion. So a little bit of a tip for anions derived, I should put iron in there, from oxyacids, is that like the 8 for nitrate and the ite for nitrite having one less oxygen, you have the same pattern. Let's take the chlorate. Chlorate is ClO3 minus. So subscript 3, superscript minus. So chlorate, I can't even talk today. Chlorite would be one less oxygen than chlorate. So ClO2 subscript minus superscript. Okay, so it has one less oxygen. Now, because the halides readily bond with oxygen, there's actually several oxyanions beyond chlorate and chlorite, so you can actually get one more oxygen than the chlorate, and you've already used the 8 ending. So what they do then is use a prefix, which is the perchlorate ion. It would help if I'd put that in the right place, wouldn't it? Perchlorate ion. So that'd be one more oxygen, ClO4 minus. Okay. Similarly, there can even be one less oxygen again than the chlorite ion, and we've already used the ite ending. So again, we put a prefix on it, which is hypo. Some people find that easy to remember because you think about being hypoglycemic means you don't have enough sugar, right? So hypochlorite means you have one less oxygen again. So that'd be ClO minus. Okay. So let's just do another one of these and see what comes up. Okay, so the nitrate anion would be NO3 minus, the nitrite ion would be NO2 minus. So just kind of learn those relationships, right? NO subscript 3 superscript minus. Acetate ion is C2H3O2 superscript minus. Okay, this comes from acetic acid. It's the conjugate base of acetic acid, which you may have learned the structural formula like that. In ionic chemistry, in organic chemistry, we tend to gather together the carbons and the hydrogens and the oxygens like this. So then when this gains electron to form an anion, you get this, right? And what happens is it actually dissociates and loses the hydrogen. An alternative way of writing it using the structural formula is this. You may also see this written down sometimes, just so you know. So IO3 minus, okay, is following the same pattern as the chlorate versus chlorite. So this will be the iodate ion. And then the hydronium cation we already did, which is H3O plus. Okay, so I'm sorry you got to just learn those ones, but it does get easier over time.